Hello. In this case, we have a compound in which we have the hydroxyl group and the halide, and then we are being asked to transform this compound into acetoacetic acid. So let's count the number of carbons, and this could be position 1, position 2. So if you look at it carefully, what you can notice is that carbon number 2 can actually just be oxidized into carboxylic acid. Carbon number 1 has the bromide, so we can actually connect carbon number 1, let's say, to carbon number 3, so that we can form a new compound. And in this case, we are creating 2 carbon atoms, and we want it to be an aldehyde because we want to create a Grignard reagent. So we want it to be either an aldehyde or a ketone, but we need 2 carbon atoms, so therefore the best way would be to use an aldehyde, so we install 2 carbon atoms. So that means once we form a Grignard reagent from this position, we can be able to attack the carbonyl, and then we can be able to install those 2 carbons. But the problem is Grignard reagent is not compatible with mild acidic conditions. Remember, in a Grignard reagent, you can think of this as it's the conjugate base of an sp3 hybridized carbon, which has a pKa of 50. So that means anything that has a conjugate acid with a pKa below 50 will be able to kill the Grignard reagent. So therefore, we need to protect the alcohol first. To protect the alcohol, then we perform the Grignard reaction, then we deprotect the alcohol, and then we do oxidation. So we can oxidize this to carboxylic acid. Then with the Grignard reagent, we are going to form an alcohol here, which you can oxidize to a ketone. Now once we have this strategy, then we can start. So in the first step, we are going to do protection. How do we protect an alcohol? Well, the best way is to use silyl trimethyl chloride in the presence of triethylamine. So that is going to form PrOTMS, trimethylsilane. Okay. Once we generate this trimethylsilane, then the next step is to form a Grignard reagent, MgBr connected to OTMS. And then in the next step, we can introduce the aldehyde followed by a source of proton. Now, when we use acidic conditions in the second step, that is after we have done the Grignard reagent, then that's going to install an OH, that is the hydroxyl group. So we're going to have this compound. 1, 2, we're going to have that OH, and this is going to attack so we have 1, this is 2, this is 1, this is 3, and that is 4. So when we use acidic conditions, it also does the deprotection. It does the deprotection of the OTMS, and we end up with an alcohol. And after this, we just do oxidation. Once we do oxidation, we end up with 1, 2, 3. Carbon number 2 is going to be oxidized to carboxylic acid because it is primary alcohol. Then carbon number 3 is going to be oxidized to a ketone, which is similar to the product we have here. Let us perform a reaction mechanism involving a Grignard reagent. Now, Grignard reagent gets inactivated under acidic conditions. So always make sure that you include them as different steps, okay? So what we're going to do here is to, first of all, use the Grignard reagent to perform the Grignard reaction, MgBr, which stabilizes the charge, the minus charge here. So we're going to use the lone pairs of electrons to do a nucleophilic attack. That opens up and we end up with 1, 2. We don't have to include the hydrogen. This now becomes the CH3 we have installed. And oxygen. Remember, although we don't include, we did not include the lone pairs of electrons, you should always make sure that you know that they are there. So right now we have 1, 2, 3 lone pairs, so the formal charge is minus 1. In the next step, now we need a source of proton because we have already installed the alkyl group. So the source of proton is going to come from the protonated water. Again, we use the lone pairs to do proton transfer. That goes there. And we end up with 1, 2, and OH, okay? And of course, plus water. Thank you for watching and have a good one.